Hi everyone. So we are continuing with the topic sectional solids. Today we are trying to solve a question of sectional solids in which the section plane is perpendicular to HP, inclined to VP. So this is the question. A right circular cone of 100 mm base circle diameter and 150 mm height is resting on its base on the ground. It is cut by a vertical plane inclined at 40 degree to the VP, the plane being at minimum distance of 15 mm from the axis of the cone. Draw the sectional elevation. Also project the true shape of the section. Assume that the section is in the front of the axis. So here the question seems to be the dimension is very large, that means 100 mm base circle and 150 height. So let us do the problem in a reducing the scale 1:2. So all the dimensions reduces to half other than the angle. Angle remains as 40 degree itself. So let's go to the solution. This is a step 1. Since a cone is resting on its base circle on HP, you are sure that you can, when you look from the top, you can see the circle, and in the front view you can see the triangle. So you draw a circle of the given dimension 1:2 dimension, that is we will mark it as the original dimension, but we are marking it as scale 1:2, but the dimension is marked as 500, but it is actually 50. So in 2.5 radius you draw a circle and aim the circle as A, B, C, D, E, F, G, H. Project it upwards, take a height of 75 and mark it as the corresponding, draw the corresponding triangle, mark it as A dash, B dash, etc. O dash, B dash. Okay, so this is the symbol position of the given figure. Now the cutting plane is inclined to VP and perpendicular to HP at a distance of 15 mm in front of the axis. So in order to, the condition is from the point of the axis, the distance to the cutting plane should be 15 mm when you measure it perpendicular to the cutting plane. So and also it should be inclined at an angle of 40 degree to the XY line. So in order to draw the cutting plane, you draw an arc of length 15 mm. Here it is 1:2 scale, so 7.5 mm, 7.5 mm, and taking an angle of 40 degree. You draw the cutting plane. So the cutting plane will pass it as like this, which I drawn in green color. So you can see that. Now the next step is you have to mark the corresponding cutting points. So as it is passing through the point so not point A, it is AB, I am marking it as 1. I am not marking all the points as the cutting points. So here it is ABT is equal to 1, OA 2, OH I am not marking, OG is equal to 3. You can mark OH, I am marking OG equal to 3 and GF equal to 4. And correspondingly you project upwards in order to get the corresponding cutting points in the front view. So 1 dash, 2 dash, similarly 3 dash. So when you project upwards, you won't get 3 dash because 3 dash is won't meet at any point on OG. So in order to get that the 3 dash point, you measure the distance to the point 3 and take that corresponding distance along the true length. I am considering OE as the true length. So take that along OE, project it upwards to O dash, E dash. That is, I am marking it as 3 double dash. From that you project it to OG, so 3 dash. So that's why you are getting the point 3 dash. I repeat once more. You take the distance from the point O to the point 3 along OG. Take the same distance along OE to get the point 3 along OE. Project it upwards till it meets the line O dash, E dash, and project it to the OG. So you will get 3 dash. Once you get the 3 dash, you can join all the points 1 dash, 2 dash, 3 dash. In OH is also 1 point, you can mark it as 5, no problem. 1 dash, 2 dash, 3 dash, 4 dash. So this is the sectional view. now in order to get the true shape, you can see here I am marking all the points. OH I am getting as 5. You can give it as 5, no issues. In order to get the true shape of the section, you consider another line which is parallel to the cutting line or cutting plane. So that is I am marking it as x dash y dash, and projecting from all the cutting points, that is from 1, 2, 3, 4, I am drawing perpendicular lines to the x dash y dash line, you can see here. And you measure the distance from the point. In order to get the point 1, you measure the distance of 1 dash to the xy line. Since 1 dash lies on the xy line, 1 lies on the x dash y dash. Then 2 dash, you measure the distance from 2 dash to the xy line, mark it along the projection line of 2. Similarly 3 dash to the xy line, mark it along the projection line of 3, and 4 dash. Now you join all the points 1 dash, you join the point from 1, 2, 3, 4, etc. You will get the true shape of the section. Now this is the final solution of the given problem. You can see I am marking the point 5 also. You can mark along 5. You can while you are drawing, you can take the point 5 also, because in order to get an exact shape, you consider maximum points. Generally these type of problems are solved dividing the circle into 12 pieces. So you will get so many close points, so you can join it very easily, so you will get the exact shape. Anyway, this is enough. You divide the circle into 8 pieces. You mark all the points. Now you just measure the value of HB and wrote it. So that's all about the given question. Thank you.